Hi, welcome back to C Programming. We need to talk a little bit about the Unix system interface. If you do most of your programming in Windows on a Windows Win32 or 64-bit machine, doesn't really matter, but anything that is not Unix or Linux, this is not going to impact your typical programming day. However, if you'd like to know a little bit more about what goes on in a Linux system, just the way some things are put together, this may be of interest to you. Everything in Unix, whether it's a printer, a file, the screen, the keyboard, whatever, is represented by a file. It's treated like a file. It's read from and it's written to, and all of the access control is handled as if the item were a file. All of these devices are represented by file descriptors. The first three of them we already know. FD0 is a standard in. We know it as standard in. FD number 1 is standard out, and FD2 is standard error. The shell, when it creates our C program environment as the program starts, handles the redirection of file descriptor 0, 1, and 2. To do what we know as the normal input, which is typically the keyboard, the normal output to the screen, and standard error output to the screen. If we do some pipelining or redirection, taking from a file, giving to a file, just the way we saw several chapters ago, the shell in Unix is responsible for setting up standard in, out, and error to point to the correct file descriptors. If it has to open new files for reading or writing, it is going to check to see whether you have permission to read those files or write to those files or do what you're telling it to do based on your group and user permissions, who you are and what groups you're a part of, and who the file was created by, and who's allowed to get in there, what groups and users are allowed to read or write or execute or so on a particular file, and in this case a particular device. Our program never needs to know if it's reading from a file or writing to a file, because everything's a file as far as we are concerned when we're running on Unix. So we don't care. We use standard in, out, and error. We have used those because the standard C library does the fix-up from the file descriptors to those names that we know. And printf, scanf, those kinds of functions do yet another fix-up to default to using the standard in, which defaults to using file descriptor 0, which defaults on farther down in the stack to the normal input, which is the keyboard file, set up by the shell. So we're relying on all of these layers all the way down through. And that's one of the things that makes C so portable, is that all we have to do is get the standard library set up properly and get a shell that understands what we're trying to do when it kicks off the program, and we're on our way. So that's just the beginnings of the Unix system interface. We're going to take a look at how to actually use the read and write calls and some other things to do some simple things in Unix. So we're not going into any big in-depth system descriptions here. We probably went about as deep as we're going to right now. So let's go on forward and take a look at a couple of the actual file calls to read and write to these devices. As we know, they're always files anyway, but we'll move right along.